Hi everyone, welcome to another episode. I know it's been a really long time that I made any videos solving any algorithm or data structure question, but I'll try to be more regular. It's been a very hectic schedule for me and I wasn't getting much time. But let's not waste more time on any other discussion and let's get to the question of the day. So, today, the question that we are going to discuss was asked in Twitter. Basically, you are given an e commerce website and you want to record the last n order IDs in a log, right? Now, you need to implement an API so such that the API has two functions. If I hit a record function with the order ID, it adds the order ID to the log, and if I hit get last of I, it gets the ith element from the log, right? I is guaranteed to be smaller than or equal to n. So you should be as efficient with time and space as possible. So before jumping on to any optimization, let's try to do it in a very brute force and simple way. um, I'll quickly open my paintbrush and we can discuss the approach. So we have two methods, right? One is reorder and use send order ID, and the other one is get last, and you basically return the ith last element from the log, and I is guaranteed to be smaller than or equal to n, so we don't have to worry about it. So let's like take a look. Initially assume that my log entry is 0, right? Because haven't received any streams of log. So let's start my counter. So I'm taking a counter variable which basically tracks how many logs I have received till this date, and obviously it's gonna get capped on max value it should go is n. So the way it should work is, let's say for simple purpose, let's say our n is 5. Now I have an array, let's say, of 5 spaces, right? Now initially my array is empty because I haven't received any logs. Now as soon as a logs come in my stream, I start inserting them in the array and I increment my counter. So at that time I'm gonna increment it till I reach n, right? So once I max of n, like I reach max of n, let's say the order ID is a b c d e. Now let's say an order ID of f comes in the stream, right? It's record, sorry, never mind, my handwriting is bad as usual. So now the next order ID is f, right? But our log is maxed out because we are supposed to store n or n size logs only. So what we do, we obviously are gonna remove this a because it says to record the last n order. So that means I'm gonna replace the oldest entry, right? So I'm gonna remove a, I'm gonna append f on this, right? Similarly, once I get any other order, I'm gonna replace the first, basically I'm remove the first one and I'm gonna insert at the end. Now this basically is the functionality of our record API, right? So on the in the record API, what did we see? Let me brief out. First, keep counter value plus plus till n, second once n reached um, first remove and insert, right? So these are the two functionalities that we need to take care of when we are implementing the record API. Now what about the get last I? So because it's an array, let's say I pass in get last a equals to, let's say, 2. So what can I do quickly here is, I basically have C at 2, right? Because it's B, the log stream is B, C, D, E, F. So I have C at 2, so I return C simply because it's an array. So this is gonna take O of 1 operation, right? Because if I'm storing it in array, it basically takes O of 1. It's simply accessing that index and giving the value. But for the record, also, we just need to remove it from the beginning and insert the order ID in the end, right? It seems like there must be some data structure that could do this, like we can pop from the beginning, insert from the end, right? uh, and if we do that, this also becomes O of 1 operation. Now, which data structure to store, which basically acts as an array as well as provides this functionality of inserting and popping from both the ends. So there are many data structures inbuilt on C++ and on Java, I guess. So I am more proficient on C++. So there is a I think is DQ, yeah, TQ, yeah, library in C++, which basically has functionality to append and in remove from the beginning and end. So you can see it has functions called push underscore back, which basically adds the element at the end in O of 1's time, and there is a functionality called pop front, which deletes the first element. So basically it gives us the functionality of inserting and deleting from both the sides, right? now and also it's like an array, so you can easily what do you say access the elements in O of 1 time. We can, I think there might be some code that we can take a look at this. So, and let's say DQ similar in Java. So what do we get? TQ interface in Java. So there is an interface in Java as well. That is cool. DQ example. Okay, so it's creating its own DQ. Linked list, yeah, actually linked list is the class, so we can easily implement this using linked list class in Java. So linked list Java, yeah, linked list in Java basically has support for inserting and deleting from the end. So we can take a look. Okay, remove first, removes and returns the first element from this list, and there should be an insert as well. Remove, this is remove, this is, and then there is an index of which basically acts as an array, so it gives us an O of 1 time. And then I think push, yeah, pushes the element onto the stack. So basically this basically pushes to the end of the list. So a linked list is the appropriate what you can say data structure that you can use to implement both the APIs. So obviously using that by using linked list data structure in Java time complex complexity is O of 1. Space complexity will be O of n, right? Because we'll be storing n size, max n size, in worst case logs, for our record. So that is it. This is the proper solution. Hope you guys enjoyed this video. If so, please like this video and subscribe to my channel. Thanks everyone.